Okay, so for this battery, it is also going to Australia, just like the one in the last video. But in the last video, I failed to mention an important thing about Australian batteries. Okay, Earth is round, right? Okay, this is up to us, right, in the west, or in the northwest. Okay, but in Australia, okay, way down there on the other side of the planet, see, the battery's going to operate in this orientation relative to how it's built. So you have to consider that and design it in such a way that the electrons won't fall out. Okay, so this is a 20S5P, okay? So that's 20 cell groups in series and then 5 in each parallel group, okay? So that's going to be 72 volts, and with these cells, it's 5, 10, 15, 20, 25, 25 amp hours, okay? So this is main battery positive, okay? So check it out. Remember, it's right here, okay? You see what's happening there? Okay, so you got 5 cells all connected at the top. Well, they will be. Okay, and they're going down through this way, right? And they're all connected here. Boom, over this way. You see what's happening? Okay, and it's going up through these 5 cells into here, so on and so forth. Okay, and here is the path. So it goes like, it's a big battery. Okay, it goes like this. Okay, we're going this way, yeah, and then here we are at the end. Okay, so as you can see, these are relatively thin going this way. Okay, this is going to be an odd shape, but about the same width. Okay, and up here though, it's going to get fatter. Okay, it'll probably be fine, but it's important for everything to be as electrically consistent as possible. Okay, so on these larger, fatter connections, I'm going to make it like the other battery, no braid, just copper and nickel. Okay, but on these smaller connections, they need some reinforcement. So I have this method. It's totally proprietary. I mean, anybody's welcome to use it, but nobody but me does. Okay, and this is a very thick relative to normal copper braid. It's tinned to prevent corrosion. Not that it matters. The battery's pretty well sealed, and this copper is not tinned, and it's regular to use that for building batteries. Anyways, the point of the matter is that this adds a significant amount of reinforcement, electrical reinforcement to a given battery. In fact, okay, so nickel alone, like all size being equal, is about 4 or 5 times less conductive than copper, okay? So let's just say it's about 20% as conductive, give or take, right? Okay, well, nickel and braid is about 80% as conductive as copper, okay? Just one braid and nickel. Okay, so because I'm mixing braid and copper, these connections are going to be really, really good. And I don't want these connections to be better. I want them to be the same. Okay, so I'm not going to do the same as possible. I'm not going to do braid on the top there. Okay, here's the braid. Just so you can get a good look at it. It's very thick this way and very thin this way compared to normal sheet metals, but it's very effective. Just one, like I said, just one is 80% as good as copper and nickel. So 2 of these is it's actually better. Okay, so I'm doing a nickel on copper on nickel weld. Okay, so I've just learned that because I do like about 80 for this welding, and then for this welding here I'm going to do 41.6, just because it's close to 40. It's enough. It's close enough. Within 1 or 2 or 3, you're not. It's fine. Okay, so this is how we do it. It's very straightforward. The more connections I make, the more careful I have to be. For example, if this was the first connection, I wouldn't have to be careful at all. In fact, if there was no connections made, I could literally put a sheet of copper over the top of it and touch it, and nothing bad would happen. But that's because no cells are connected at that time. But now, more and more cells are getting connected. So I have to be careful. I don't know which cells I have to be careful with, because that makes it dangerous when you have to think what is safe and what isn't. So I just know that the battery is no longer safe to be willy-nilly in that way, if that makes sense. It's gone from you don't have to think about it to don't even risk it. Just that quick. Because yes, I have definitely dropped things on batteries and had them pop, and then I have to fix it or just start over because, it hurts something, etc. That cost me money and time, blah, blah, blah. You can see how the new nickel I got in the mail doesn't 1000% line up, but it does enough. It's fine, and the quality of the metal, it seems very, very good. Okay, now it's easy to get these crooked bad because it's like hump shaped, so you have to be vigilant. Oops, see, I slipped there. There we go. There we go. Okay, that's all right. Okay, so there's that one. There we go. You want as little air gap, like no air gap, basically. I don't know why I said as little. You want no air gap anywhere, like not between the probe and the metal on top or between the metal and the metal underneath. You want no air gaps. Contrary to how you might think, okay, you don't want to push down the probes as much as possible because like I said before, spot welding is a resistance operation, okay? And the more you press, the better connection you get, which is actually worse for spot welding. You don't want a awful connection because it'll pop, okay? You know, and burn something. But if you get too good of a connection, the voltage drop will not be high enough. The resistance will not be high enough. And you will get a weld, but it won't be the strongest weld, and it could even be a bad weld. And that's, no one wants that. But because this is like several, this is like the fourth layer, it matters so little. You know, you want to do it perfect, but this is the least, this layer requires the least level of diligence in terms of welding. It requires the most diligence in terms of alignment because, you know, it's on top. Well, actually, no, the very bottom layer is the one that matters the most for alignment. Then every subsequent layer after that, you know, etc. Okay, I'm rambling. Okay. Again, this battery's going to Australia, so we're going to overkill it and just do this. Damn it. Okay. I got this piece. Okay, but I gotta cut it. Now, what I'd normally do is I'd cut this flush right here, and then right here. But like I said, these are not exactly the same, and it's annoying. I'm not worried about conductivity or anything being different, because it's absolutely like it's probably 0.5% different in that way because it's the same thickness and same width. It's just that the slit holes are not, you know, they're not the same. Okay, I gotta cut this piece of braid. And this is how I do that because I suck at measuring everything. I do everything guess and check or with some sort of reference, which is basically a single shot or zero shot guess and check. I have no idea how many millimeters this is, but it's exactly this long. Okay, I could have cut that better, but let's see. Nope. Could not have cut it better, actually. It is perfect. See, look, if I'm willy-nilly about it, you know, anything could happen. And look, this has, like, flex in it. What I could do, and I didn't do last time. There we go. That'll make it easier. It's less likely to... Because I've set them down, and I think it's fine. I literally lift my thumb, and it arches up and falls over, and it is a bad day, folks. Seriously. It's very loud, very bright, very hot. Luckily, every time that's happened, it's just been a quick thing, you know. It's never been a catastrophic chain reaction. It could, don't get me wrong, if I drop a whole slab of braid on it, just on a real bad spot, it's going to ignite that braid if I'm lucky. If I'm not lucky, then the braid will not act as a fuse. It will handle the current long enough to cause a chain reaction inside the battery that causes a thermal runaway effect that ends with your house releasing all of its magic smoke. And nobody wants that. Okay, I'm satisfied with that level of alignment. I'm telling you, I need 16 fingers. I bet a guitar player would be really great at this. Okay, see, I'm nervous about alignment, so I just have to... See, there's no reason to be nervous. Confidence. Okay, there's one. With these, you really got to corner it like that. I mean, you can't just most of the time because it will... And then you'll get down here and it's like an inch up that way. Not an inch, but you know what I mean. I just like inhaled vaporized nickel. I taste it. That can't be good. Workman's comp. OSHA. And the probes are too hot. Gotta wait for these probes to cool, man. I can tell they're getting hot, and as the probes get hot, the resistance goes up. As the resistance goes up, there's a greater voltage drop. Okay, so it messes my whole situation up. Gotta wait. Almost missed it.